Hello everyone, I'm Yuan. Today I'm going to present our paper An Instrument for Measuring Users' Meta-Intents, which cooperate with Team Dunkers, Team Klima, and Professor Ziegler. This presentation consists of 4 parts. First is the introduction of conversational recommender system and the relevant design challenges, especially in the user interaction aspect. The second is about meta-intents. That is the concept that we develop to facilitate solving challenges and improve CRS. Third is the analysis of meta-intents and establishing the links between stable psychological characteristics and meta-intents. Last is the conclusion. Let's go to the first part. Design challenges in conversational recommender system. CRS have been gaining increased attention in research and industry in recent years. Conversational techniques can be distinguished between natural language-based, form-based, and critiquing approaches. Due to the considerable development of natural language processing, natural language-based CRS has become the popular research subject. In this paper, we focus on the natural language-based CRS. The design challenges in the CRS can be distinguished into conversational level and recommendation level. In the conversational aspect, CRS dialogue flow should follow the user's decision process and providing sufficient flexibility to be concrete. The one point is, should the CRS be system initiative or user initiative? This is depend on users' knowledge and preference. Different users require different schemes. The second point is, should the CRS provide long question sequence or the short question sequence? Also be well known as a trade-off problem between preference elicitation and recommendation. The third point is, dialogue questions need to be formulated at a level that is appropriate for the user's knowledge and goals. For instance, the usage level questions are about intended use of the product. Technical level questions are about some specific technical features. The following points are, should the system answers be neutral or human-like, with a long sentence or short sentence. Response should be shortcut through GUI elements or just a text sentence. For the recommendation level challenges, the recommendation should be presented in appropriate numbers and appropriate level of detail. To be concrete, more or less diversity in recommendation side, a long recommendation list or short one, recommended product with more parameters or less. Different user has different preference. To solve these challenges, we develop meta-intents to describe this kind of higher conceptual level preference. In second part, we propose meta-intents concept and build up a reliable instrument via two-stage study. CRS could offer user personalized recommendation via eliciting user product preference through their predefined question flow. However, they maybe ignore the user's interaction preference and lack ability to adapt themselves to fit user interaction preference. As we know, product preference could be highly various in different domains, but interaction preference should be pretty similar and be able to unify it across different domain and different interactive user interface. For example, I'm the person like to find a suitable product as soon as possible, rather than explore all the options. For this kind of interaction preference, we could summarize it into efficiency orientation. We call this efficiency orientation the meta-intents factor, as it describes high-level preference. We hereby define meta-intents. Meta-intents are several factors that reflect user high abstract level interaction preference. For CRS, we propose a total of 12 meta-intents factors, and we describe them one by one. Task focus factor indicates how well defined the user mental goal is. Users with a strong task focus are less likely to consider unplanned products when shopping. In this case, recommending novel or advertised products may interfere with the user's goal. Users with lower task focus, in contrast, will react to seeing unplanned products when shopping, and promoting new products may improve the user shopping experience. In CRS scenario, task focus can indicate whether to show novel and promotional products in the recommendation list. Openness for guidance factor indicates users' willingness and acceptance of system guidance. In the research and the decision process, a considerable number of users are reluctant to be strongly guided by a system and may prefer to explore available options by themselves using search or filtering techniques. User initiative. This meta-intent refers to the user preference of initiating and leading a dialogue rather than reacting to the system questions. Users' initiative allows users to express their preference more freely and provide them more control, but at the same time, put more burden on users' memory, where desired item features need to be remembered and recalled. System initiative. Users who prefer system-initiated conversation tend to interact with the CRS in a more passive and reactive manner. This style of interaction has less demands on the user's domain knowledge and benefits from recognition instead of recall memory load. Preference for system initiative is logically the opposite of the user initiative, as we mentioned in last factor, but we want to access the two factors separately to see whether this is also the case in user perception of the CRS. Efficiency orientation. This meta-intent refers both to the time spent in a recommendation dialogue as well as the number of interaction steps. It's an important factor to get the length of the dialogue, provide an acceptable trade-off between preference collection and recommendation, ideally resolving the exploration and exploitation problem in CRS subject to the user's efficiency orientation. Human likeness. This factor refers to the question of whether users prefer an anthropomorphic or a more neutral factual style of interaction. Human likeness can be achieved by a number of means, such as including in the dialogue greetings and chit-chat, using a personal style of language, or by embodying the agent in an animated character. Choosing an appropriate level of human likeness has been shown to have considerable impact on user experience. Interest in detail. This factor describes what extent the users pay attention to details in the search product. Some users may want to view all features and obtain a comprehensive understanding of the product. In contrast, other users may only be interested in the features they care about and are unwilling to spend time on other features. Concrete design implication could be asking feature level or usage level questions in the dialogue and the extent of the features pretended for a recommended item. Also, whether unimportant features should be left out or folded away in recommendation panel. Comparison orientation. This factor indicates how much users like to use the comparison function in the context of CRS. Comparing items or features allows users to express their preference in a relative rather than an absolute value. It provides guidance for the functionality design of CRS. To be concrete, comparison can be realized by letting user ask comparative questions or by providing comparative explanation in the dialog flow. Scope of choice. This factor indicates users' preference for the length of the recommendation list. Longer lists provide user with a great scope of choice, which may increase the attractiveness of the recommendations, but also increase choice difficulty, whereas shorter lists may reduce cognitive effort and facilitate decision-making. It can be useful for a personalized recommendation panel. Diversity orientation. Some users appreciate exploring unknown item types, but for others, high diversity will increase the difficulty of decision-making and the effectiveness of the recommender. It can be useful for personalized recommendation. Critiquing orientation. This meta-intent describes whether users are willing to use critiquing-oriented function in a recommender system. Critique is a technique that the user can express preference by modifying product features. Linking preference elicitation to a specific recommended product can serve as a cue for elaborating or remembering one's preference. Explanation orientation. The final proposed meta-intent refers to users' perception of explanation that are provided by recommendations. Explaining recommendation helps to improve transparency, persuasiveness, effectiveness, trustworthiness, and the satisfaction of recommendation systems. This indicates that the perception and acceptance of explanation may differ among users, and it may be important to consider this preference when designing the CRS dialog. To get a reliable instrument, meta-intent instrument, when we conduct a two-stage study, this is the first exploratory stage. We introduce the study design. According to the previous 12 meta-intent factors, we form a total of 59 question items for them. We have positive questions and negative questions for each factor. And then we build up a questionnaire, start a user study through prolific platform. Our user study includes 212 participants and in 3 domains: smartphone, hotels, and a general scenario, which is a between group design. And all questions items are completely randomized for the participants. When we get the data, we conduct exploratory factor analysis to filter and update 59 predefined question items. So to run the EFA, we use PCA to extract factors with criteria eigenvalue greater 1. And the EFA results finally generate 18 factors. According to the EFA results, we filter and update out predefined question items, and the criteria are shown in the text. Finally, we got 8 factors and 24 question items, and we continue to do second confirmatory factor analysis to validate this questionnaire. This is the second confirmatory stage. We introduce the study design. So after the first stage study, we build a new questionnaire with 8 meta-intent factors and 24 question items. And we start a user study again through prolific platform. Our user study includes totally 394 participants, also in 3 domains with a between group design. And all the question items are block randomized for the participants. When we get the data, we conduct confirmatory factor analysis, validate, and get the final instrument. We have 394 valid participants and 3 domains for CFA, and we also use PCA to extract factors, but with a fixed factor number, which is 8. The results show that 7 factors finally pass the validity test and reliability test. These 7 factors are dialogue initiation, interest in details, human likeness, scope of choice, explanation orientation, task focus, efficiency orientation. Following is the third part, meta-intense analysis. We want to study the domain, gender, age, influence on meta-intense, and the relationship between psychological traits and our meta-intense. So first, we show the histogram of the meta-intense. We can see most of them close to a normal distribution. For interest in details and the human likeness, there is a little bit skew normal distribution. For comparison, we also show the histogram of decision-making style, include the rational and intuitive factor. The distribution of meta-intense value is within a reasonable range. In our user study part, we have between group design for 3 domains. So here we can study the domain influence on meta-intense. We conduct a one-way ANOVA test on 3 predefined domains. After BH procedure, we cannot find any significant difference for every meta-intense factor, which means meta-intense are not significantly impacted by domains. We study the gender influence on meta-intense. We conduct a t-test on male group and the female group. After BH procedure, the significant difference only observed in human likeness, but not for others. This means most meta-intense are not impacted by gender. We analyze the decision-making style influence on meta-intense. To do so, we first apply k-means clustering to assign participants into 2 groups, depending on their rational value and intuitive value. So finally, we get 2 groups, rational group and the intuitive group, and then conduct a t-test between 2 groups. The results show that the rational group and the intuitive group have significant difference in 4 meta-intense factors: interest in details, human likeness, explanation orientation, efficiency orientation. In order to quantitatively analyze the impact of decision style and age on meta-intense, we conducted a structural equation modeling analysis. The analysis of age did not reveal a large impact on meta-intense. For decision-making style, we found rationality clearly and positively impact interest in details, scope of choice, explanation orientation. Intuitiveness clearly and positively impact human likeness and efficiency orientation. Following is the last part, conclusion. In this work, we define meta-intense as high-level user preference for the conversation and information presentation in CRS. We validate meta-intense factors in 2-stage approach and get a reliable instrument with 24 items for measuring meta-intense. We found meta-intense are significantly influenced by the general decision-making style and therefore can be linked with stable psychological characteristics. We found the meta-intense are domain, gender, age independent. We also want to point out some limitations of this work. Firstly, our user study is based on a pretended scenario instead of a real system. Secondly, we use t-test and ANOVA to analyze the influence of domain, gender on meta-intense. For strict independent test, we should do toast procedure. This could be a part of the future work. In the future work, we are going to integrate meta-intents in a real CRS and analyze the real impact of meta-intents on user. Thanks for your attention. Any questions are welcome. Thanks.